This is going to be a video primarily about replication in Arc with some common practices. So the first things first is we're going to make a singleton. A singleton is an actor that exists in the world with only one instance. We'll make a new blueprint, and it will be a save game actor. All this means is that once the actor is spawned in the world, it will be saved on world saves, and it will exist next time the server reboots automatically. You can name it whatever you want. A common name for things is either starting with Singleton or CCA, which is just an Arc alternative name for a singleton. And then add it to your mod data asset. Make sure you fix the mod data asset caching bug that still exists in Arc. It was mentioned in a previous video. It involves removing your primal game data VP from the world settings file, starting pi, stopping pi, and then adding your primal game data back into here. Otherwise, any changes to your mod data asset will not be recognized until you either do this or restart the editor. Now that we have a singleton, what do we do with it? Well, by default, they are server-only actors. They have replication that's turned off, which can be enabled if you want, but most people do not need it. In this example, we're just going to use it to add buffs to players when they spawn, but there are countless other features you could do. You want to get the game mode, cast to shooter game mode, and off of there, assign. These are all dispatchers available to the game mode. If you don't know what a dispatcher is, you can look up previous videos for generic Unreal Engine tutorials. There are things like killed. This is when anything dies. It's a little spammy, so avoid using it unless you actually need to. But the one that we're going to use today is the shooter character spawn one. On shooter character spawned. This event will fire anytime a player spawns. A player spawning doesn't necessarily mean just entering the world or dying. Things like fast traveling between beds also count, so keep that in mind. We're going to be adding a buff to our player when they spawn. And just for this example temporarily, we will put in just a shiny sparkly one. The only problem with doing this is that this bind often doesn't get set up fast enough when using Singleplayer or Pi, especially in Singleplayer mode, which we will test right now. As you can see in the corner, there's no sparkly buff, so it didn't work. But if we killed ourselves and respawned, it would appear. The solution is pretty simple. Right after setting up our bind, we'll put a small delay. Doesn't really matter too much, just something fairly short. And then we're going to get all the controllers. The controllers would be any characters, any clients that are currently connected to the server, or in single player, the only player that exists. From the controller, we can get the character it's associated with. Get shooter character from controller. We will buff the character, and we will add in our sparkly buff again. It worked on single player. And if we try it on a server environment, it should also work. Still sparkly. Another way of doing dispatchers, rather than this connected event that has to happen on the event graph, is by using a custom one. You can pull off of here, and go to Event Dispatchers, Create Event. And it will ask you for a function or an event, or to create a function or an event. So if you create a matching function, it will create one of these in the functions list with all the associated input pins. We'll call it something sensible. We will add our buff back in here. You can get rid of this. And here we can just call that function. And we're still sparkly. Something else fairly common with game modes and singletons and dispatchers are script commands. You pull off of the game mode and you do a bind event on actor custom event. This event will fire anytime someone uses a script command. Script commands are server only and admin only because they start with the cheat prefix. Just to show what they can do, I'll buff the player. Only when they use the script command. Just as a silly example, if someone uses a script command and says hello, they will get buffed. The instigator actor is an actor object reference, but it will always be the player controller, unless used externally from Arc, but I'm not going to cover that in this instance. We will get the shooter player controller and then the character from that. And then once again, we will call our buff player function. And they should get buffed when they use the command. So you bring up the console, cheat script command, and then your command name. And we get sparkly. Building off our singleton that buffs the player, we're going to create our own custom buff that will do some minor replication. Mostly it will use hotkeys and then it will destroy targets. First you need your own buff. So create a new blueprint. Primal buff. You can name it something, whatever you wish. Back in our singleton, I'm going to just destroy all this. You can move it or ignore it or whatever. And reattach our spawn events so that we can get our buff automatically without having to add it to ourselves. Get rid of that. In our buff player, make sure you add your buff. I'm going to create a variable just because. In our buff, just to make sure we're not confusing ourselves, give it something, some name, whatever. And I'll pick a fun icon. One of these party hats. And we will be using the setup for Instigator function. BP setup for Instigator. It's much like the event begin play, except it has a few benefits. Namely, it comes with the input pin for the instigator. Event begin play can often run early, and there's no input pin. So if you try to use instigator or any of the networking commands, sometimes they don't work because they haven't been set up properly. They haven't been finished setting up. And you often have to put in delays, which can be annoying and cause issues themselves. Buffs themselves have countless functions. There's no way I'm going to go through any or all of these. They are fairly endless. They involve dynos, inventories, players, buff settings, all sorts of things. But they are very often used because they give you a reference to a single target they're attached to, and it allows for proper replication techniques. For our setup function, we want is locally controlled by player. This will only fire if the instigator that it's firing for is the character it's attached to and not anyone else. So when the buff is replicated to other clients, this would normally fire, but we don't want them to be able to run any code past this. We only want it for the player that the buff is attached to. That's where this is. So if this is true, we get the instigator, get owner controller. We then enable input. And then we will use the F1 key and an input action for use, otherwise the E key. The difference between the two is this is always going to be F1, and this will always be the use action. So if someone rebinds their use key from E to O or minus or L or something, this will still fire. If you used E specifically, like this, it will always be E. It won't necessarily be use if someone rebound their keys. So keep that in mind. These checkboxes will prevent the normal action from firing. So if you use the use key and you keep consume on, no one can use the use button, which is usually not a good thing. We'll turn them off. Just to test, make sure we did it right, we'll just do a little print string. Make sure both are firing. Make sure you connect here. Almost forgot it. So we have our buff. E works. And F1 works. We can close the singleton for now. Don't need it. Same with the MDA. Don't need that. Next, we're going to create a line trace. We'll create our own little function just to clean up the graph a little bit. Have both of the inputs call the function. We need the controller. You can use the getOwnerController for the buff. There's also a getInstigatorPlayerController your function. Both work just fine. There are tons and tons of trace functions. Box traces, channels and objects, capsule traces, line traces, multi-box traces, etc. Line traces are good for accurate, but too accurate, in my opinion, line traces. So they're fairly pixel accurate, which can get a little annoying when you almost hit something but don't quite, which is generally why I use the capsule traces. Capsule is like almost like a sphere, but you can change the radiuses and the heights to make it oddly shaped if you wish. We're going to do a trace for structures. And I like 50 as the radius and 50 as the half height. It's a good size. It might be a little big sometimes, but you can see what it looks like if you turn on the draw debug type for duration. Go. So you want the get actor location. From the player camera manager. This way it goes in the direction that you're looking rather than the direction your character is facing. Don't need that. The end will be the forward vector of the camera manager. Times a distance. This is unreal units, so centimeters. 300 is generally about 1 foundation, so we want about 10 foundations. Adjust as necessary. You add that to the starting location, and that is the end point. All of these other things you can turn on if you wish, so you can. These are the hit results, and whether or not it was hit. So we will check if it's hit first, and then we will print off the actor that got hit. And we'll see what it does. This is what the half height and radius does. It gives you a sphere or a ball-shaped object like this, and it travels along that path to the end, still as a ball or a sphere. And when you hit something, it goes green, and you should see in the corner the print strings. So in lots of cases, this will be too big because you can see the sphere is like the size of a window or the better part of a person, but you can just shrink it down in the graph. Just adjust this, maybe take it to 25 or something. Now what we want to do is we want to take the target, if we hit one, and destroy it. But these are all running on the client. All input actions are client-sided. Only the client runs them. Server doesn't have a keyboard. A custom event. You can call it something whatever. I usually prefix it with server underscore or client underscore or multi underscore, just so I can keep clear which functions are replicated and which ones are not. We want it to run on the server and reliable. For an input pin, we want a primal structure. And then we add this function call into our trace if it was hit. We'll have to cast first since this only returns generic actors, and we want primal structures. But since our traces only fire for structures, we know that it will always be a primal structure if one was hit. And even if for some strange reason it wasn't, the cast would simply fail. In here, we will simply destroy actor. And then we'll test it out. So we can see the new size of our sphere. It's a little better, a little smaller, but still useful in case you miss just a little bit, like this. You can tell I missed, and then I hit it just on the edge, and our structure is destroyed. While we're looking at replicated events, you can actually turn them into replicated functions. This is solely unique to the ArcDev kit and not native Unreal Engine, but you can convert the event to a function. And then on the function, you can enable all the replication settings that you wish. There's no difference other than it takes your events or functions off the graph, off the event graph, and adds them over with the function listings. For this next bit, we're going to do replication on structures. It will be adding an image of an icon from items you add to the inventory on the front of the structure. So we'll have our structure and we'll put an icon up here of like a pickaxe or berries or something when you add them to the inventory. We will also do some multi-use stuff and some Net Exec handling, which is a little bit more arc specific. So first things first is we need somewhere to draw our image. You can just use a plane. It's just a square. And we'll just line it up. You can make it as big as you want, or I'm not worried about the details really. Next thing is we'll need a material to go on it to draw our icon to. We'll make a new material. We'll need a texture. We'll also need to change the blend mode to translucent. We can plug the alpha into the opacity, gets rid of the background. And if you want some emissive colors, that would be like glow and stuff, you can do that here too. Makes that a little bit brighter. All the way up to crazy. Keep it pretty low. The effects of bloom and the emissives in the dev kit tend to be a little less accurate than they are in live. So anything that looks bright in the dev kit is probably way brighter in live. We need to get a material instance so that we can change the icon at runtime. And then we need to apply that to our plane. And there we go, some berries. Next thing we need to do is capture the item added to inventory dispatch event so that when a player adds items to the inventory, we can update the icon on the front to adjust accordingly. We'll use begin play, and we want to make sure it's not the preview structure. And only run on the server. And then we get the inventory component. And we catch the on inventory item added dispatch event. Just to show you what it'll do, we'll put in a print string and run it real quick. You can see the prints in the corner. Every time an item is added, it prints off what it was, and only on the server. Next, we're going to replicate the class of the item, not the item itself, just the class. Promote it to a variable, and we'll call it just item class. That's fine. And we want to rep notify. The reason we want this is that when it updates, we want to update all the clients that are around it. And when any clients come into relevancy range, we also want the function to fire so that they can update the icon as well. Check multicast. we'll make our own little function just to keep things stored nicely. And then we'll call that in the rep function. We want to get our plane, get the material for the plane, and see if it's a dynamic material. If it isn't, we need to create a new one so that we can call texture parameters on it to update the icon. The parent for it will be the material instance we just made. And then we will update the material on the plane to be this new material. If the cast does succeed, that means we've already done this previously. I'm going to promote this to a local variable just so we can clean up the graph a little bit. Same with here. And then we will change the texture parameter on our material to the icon that this class has. For that, we'll have to get what's called a CDO, class default object, and cast to a primal item. What this is, it will be the default values that this class has, which is fine because all we want is the item icon from it. Get the item icon from the cast. And then the dynamic material, we will set a texture parameter. Add the new icon and use whatever the name of the parameter is. In this case, it was just icon. So what will happen is someone adds something to the inventory. The class fires off this replicated variable, which calls this function. We will set dynamic material on the plane if it doesn't exist. If it does, we'll get the variable for it. We'll extract the item icon from the class and set it on the texture parameter value on the dynamic material. We'll also check the save game on the variable so that it saves in between sessions. Otherwise, the icon will disappear every single time you restart the game. And there we go, a pickaxe, our bola, pistols, bows, etc. We have a sickle. If we restart it, it should still be a sickle. And there we go. A relatively simple example of replication using rep notify variables. We'll now use something called Net Exec. This is a Arc-specific example for replication. Basically, it uses the player controller rather than actors that are not client-owned in order to do server-client communications. Basically, with structures, since they're not owned by players, you can't use typical replicated events. What we're going to do is we're going to use a player selection in the inventory screen to change the icon on the front of the structure. So we'll use multi-use for this. Just real quick, these are actually local variables in Unreal Engine 5. So if you right click on the graph, right there is a reference to this. Same with the 4PC pin. Using this is the same as using this. So it will help you with larger graphs to clean up all the lines. We'll make a new multi-use entry here. We'll just call it change icon. We'll give it some index, just keep it unique. Priorities go from technically anything, I suppose, but the higher the number, the more in front that they are. So the highest number will be the default action on the structure. So if you use any negative ones, they'll never be on that list until all the other entries are gone. We'll just use -1. We want client only because it's just for the clients to choose their selected inventory item. And we're going to stick it on the inventory screen as well, so that you can click it when the inventory's been opened. Then we want do multi-use. This is the client-sided actions for multi-use. And we'll check for our entry. And if it is, this is where we call the Net Exec functions in order to switch to the server. It needs a target of a player controller. And then the for actor is the actor that you want to switch to. In this case, it's just self. We want to go to the server for the structure from the client. Command name is to separate functions in case you want to do multiple net execs for different things. We'll just call it change icon. Check reliable. And then break this exec params. This is data that you can pass to the server from the client. What we're going to pass is a reference to the item we have selected, assuming one is selected in the first place. And for that, we need the shooter controller. And from that, we can get the get inventory UI selected item remote. This will be the selected item in a remote inventory, and the local one will be the one in your own player inventory. If this is valid, it means there's an item that's been selected. And if that's the case, we want to get the item ID for it. Just 2 integers. Connect them here. We can hide the rest of these. We don't need them. And this should fire off Net Exec to the server with the item IDs for the remote selected item if one exists. And for that, we want BP server handle Net Exec command. This is where that will go. You want to check what the command is. This is in case you have many commands. You want to know which one you need to run. We just called it change icon. It's probably best to copy and paste so we avoid typos. We want to get the inventory component. We want to look for the ID that we passed along the Net Exec command from the integers. BP find item with ID. We'll plug in our ints. Hide those. Should always valid check in case something happened to remove the item. Someone could have dropped it or something. And if it exists, we're going to get the class and update our item class variable so that we'll update the icon on the front of our structure. And that should be that. Make sure you have the multi-use rules enabled if they aren't already, otherwise none of this will work. So all this does is adds a multi-use entry. If that's the entry that gets fired, get the selected item, if it exists, pass the ints to the server. The server then fires, checks for the item. If it exists, we'll update our item class rep notify variable, which will run this function, which should update the plane on the front with the new icon that we selected. So our sickle is still there. We'll then use crossbow and we'll change the icon. And it gets updated. It's also here if you want to use it. Not that it would do you any good. Change it to the spyglass. So since this function can't actually be used because nothing's selected, we'll remove it from the radial menu. It's just this hide from UI button right there. That should do it. No longer on the radial menu, but is still in here. If nothing's selected, nothing happens. If we choose the hatchet and then change the icon, it gets updated.